This is a video series on C for embedded systems. Check out the playlist for other videos. Subscribe to the channel for more such videos. In this video, let's see what are bitwise operators. Bitwise operators work on bits and perform bit by bit operation. So here bit is either 1 or 0. So in the binary number system, this is the fundamental digits 0 and 1. The truth table for AND, OR, and XOR is as follows. So if the value of P and Q are, let's say, 0 and 0, the P and Q, that means 0 and 0 becomes 0, 0 or 0 becomes 0, 0 XOR 0 becomes 0. And if the value is 1 and 0 and 1, so 1 and operation and with 0 is 0, 0 or 1 is 1, 0 XOR 1 is 1. And for P1, Q value 1. So P and Q both are 1, that means it is 1. If both are 1, P or Q, that means 1 or 1 is 1, and 1 XOR 1 is 0. And if it is 1 and 0, 0 and operation, sorry, 1 and operation with 0 is 0, 1 or operation with 0 is 1, 1 XOR 0 is 1. So this is basically the truth table for AND or XOR operations. So the following table lists the bitwise operators supported by C, assuming a variable A holds 60, the variable B holds 13. So here if you see the variable A 60 means it is 00111100. So this is decimal 60 here, and this is a representation in binary. And for B, the value 13 is 00001101. So this is 13 in this is the binary format. Well, so C supports like AND operation. So AND binary operator copies a bit to the result if it exists in both operands. So basically what it means is that if both operands are 1, then only the value is 1. So if you see this truth table, only if the value of the bits in the operand is 1, then only AND gives 1, otherwise it is 0. So that is the understanding. So now the OR is, so binary OR operator copies a bit if it exists in either operand. So what it means is that in either of the operand bits, if it contains 1 in either of the case, it will be 1. So you can see that if both operands are 0, then only it is 0, otherwise it's always 1. So that is the understanding. And for XOR operator, XOR binary operator copies the bit if it is set in one operand but not on both. So basically it is like if the one operand is set and the other is not set, then the value is 1. That is the case with here. If it is set and the other operand is not set, then it is set. So that is the XOR operation. You have a binary ones complement. We also call it as a not operator. So use unary and the effect of flipping the bits. So whatever the bits that are available will be complemented. So bit will be flipped. So if it is 1001 and the not operation becomes 0110. So that is how the bits gets flipped. Okay, so the next operator is binary left shift operator. The left operand's value is moved left by one number of bits specified by the right operand. So that means the left shift is done for this number. So if this is the number here, the value of a is 60. That means 00111100. This becomes a, so a left shift by 2. That means 2 bits will be shifted towards left. So that is what is represented here. And similarly, the binary right shift operator. So the left operand value is moved right by the number of bits specified by the operand. So here the a value gets shifted towards right. 2 bits are moved towards right. So the value of a is 00111100. So in this case, you can see that these 2 bits are kind of moved out, and for the last 2 bits 0 gets appended. So that is the shift, the left shift. And for the right shift, you can see that 00111100. So it moves towards the right. That means these are added. 2 more zeros will be added, and these 2 will be moved out. So that is how you can interpret the left shift and right shift operators. So well, let's see this in the code. So here we have a program to demonstrate bitwise operators. As we saw, and, or, bitwise XOR, bitwise not, left shift and right shift are the operators present in C. So the first thing that we will see is and operation. So here you can see that the number 1 is 14 and the number 2 is 7. You can see the binary representations here, and the result of num1 and num2 should be 6, because and means only if I in both the operands bits are 1, then you have the corresponding bit set. So let's see this. Let's compile and see this. GCC bitwise operators, it's compiled, and a.exe. Okay, so already it is printed all of the, so it printed all of the values, but let's analyze them one by one. So we understood how AND works. Similarly, for the OR, the number 3 is 14 and 7, 1 1 1 0 and 0 1 1 1. And here OR means if either of the bits are 1, at least one bit in either of these operands shall be 1, then you will the resultant bit is 1. So you can see that 1 0 or is 1, 1 or 1 is 1, 1 or 1 is 1 and 0 or 1 is 1. So that is why you will see the value as 15. So in the next case it is XOR. XOR is basically if either of the operands are not same, then it is 1. If both operands bits are same, we will consider or it results in 0. So that is how we can interpret this. So 1 0 is 1, that means 1 XOR 0 is 1. 1 XOR 1 is 0, 1 XOR 1 is 0, 0 XOR 1 is 1. So that's why it will give decimal 8, sorry, decimal 9. And the other operator is the NOT. So it basically inverts each bit. So the number 7 is 14. 14 is 1 0. It's like it is the decimal. So the binary representation is 0 0 zeros, and the last nibble is 1 1 1 0. So the reason is that it is a 32-bit integer. The unsigned int is 32-bit now. So that is why we have to put all of this, all of the other, we have to consider all of the other values, because once we do an inversion, all the other bits becomes 1. The wherever zeros, those becomes 1, and wherever ones, those becomes 0. So we will end up having a larger number. So let's try this. So for this I have uh, this calculator. So basically what we've done is, this is the binary to decimal converter. So after this binary making not operation, so it becomes this, which is inverted. Now if I convert, you can see that this is the decimal equivalent. So 429496728 so 4296, so the same number is being uh, is the output. So that means what we're doing is correct, or our understanding is correct. Okay, so let's move on to the left shift. So this left shift operator shifts bits to the left. So here you can see that the number 8 is 5, 5 is 0 1 0 1, and if we do a left shift, so the number should become 1 0 1 0 1 0. So that means it's a decimal 20. So similarly, the right shift operator, the shifts bits to the right. So the same number 5, if we do uh, if we right shift by 1, so it becomes 0 0 1 0, which is decimal 2. So I hope this is clear. One thing what we need to understand is that if you take integers, you have to consider it as a 32-bit value. Of course, it's based on the architecture, but the bits that get added, let's say after you shift, so those will be, it will be appended with 0 either in left or the right shift. So that is something we should keep in mind. So I hope this is clear. We have seen the bitwise operators, bitwise AND, bitwise OR, bitwise XOR, bitwise NOT or the complement, left shift and right shift operators. So I hope this is helpful. Thanks for watching.
Subscribe to the channel for more projects, courses, tutorials, and tools.